question will be not same obviously, but the thing is, like it is similar kind of the questions it will be there, right? Hello.
Yeah, I'm listening.
Okay. So we will start. Like which topic are the like which you think are stronger according to you?
I have done Verilog coding, the finite state machines coding in Verilog,
Okay.
and digital design,
Okay.
computer architecture, and CMOS, the Boolean expressions of CMOS power and all,
Okay.
or
Okay.
transmission gates.
Okay.
And yeah, like GPU, little bit, and I have to revise it once again,
Okay. Fine.
the basics of it.
Okay. Fine. So tell me about the More and Millie and where we use it.
So Moore may to detect the sequence. It is the type where we detect the sequence basically.
Hmm. And Millie, like what is the difference between both them? Which what you will prefer in your circuit?
Mealy may the output is depend on the present input as well as input applied as well as the present state. But in Moore, it's always depend on the present state. So basically, I would prefer Moore in my design because it will ensure that while applying the input, my output doesn't change unless and until it is on the right state.
Hmm. 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 Okay, fine. You know about pipelining, right? Pipelining, you know.
Yeah.
Okay, fine. So can you do like so why we use pipelining basically? What is the motive behind using pipelining?
So pipelining is basically it used in increasing the throughput. So it's
Okay.
like if we have a big task, we just cut it down and we send each batch on in
Reduce
the
the
different time.
throughput. Reduce or increase the throughput?
Yes,
Reduce the throughput or increase the throughput?
increase the throughput.
Okay, fine. Okay, fine. Let have my pipelining have the 5 stage. Each stage have the one nanometer delay, and register overhead is point 0.2 nanometer nanosecond. Sorry. So tell me the speed up, like a speed up.
Register is
Register overhead is zero point 0.2 nanoseconds.
okay.
5 stages are there. Each stage have the one nanosecond delay, and my overhead is zero point 0.2 nanoseconds. You have to find the speed of factor.
So the total delay will be number of stages into the
Hmm.
time of the clock. So the max stage delay would be 1 and the register delay will be 0.2. So that would be 1.2 into 5, 6 nanosecond.
No, speed of factor. I'm asking speed of factor. Hello, I'm asking the speed of factor.
It's like speed up is non-pipeline time upon the pipeline time.
Yeah,
So
the
for
non-pipeline time is.
pipeline time, it would be 1.2 for
Hmm.
every instruction, and
And
for non-pipeline, it would be 5,
yeah,
the distance. So I'll just divide it by 5 by 1.2. So that would be the answer.
yeah, correct. 4.16.
Yeah. For
Okay, fine. So why we prefer the 60 gram cells preferred over the 40 cells RAM? You know about this thing like four
Hmm.
transistors SRAM. Okay, fine. Okay, metastability we have already covered.
1 second. I'll write it down.
Okay, fine. You know about handshake protocol?
Yeah,
Handshake protocol.
handshake protocol. I mean, like,
Tell me
I
about it.
know the basics of it. If we are sending a signal, so the receiving side have to send another bit to confirm that it has received the signal, and then it will continue its exchange.
Mhm. So where we use it?
In protocols like
Like it is used.
we use it in HFTs, actually, high frequency trading.
It is used in CDC techniques or not? Like to fix the CDC or not?
I think yes, we can use that in CDC also.
Okay, just check it also. Okay, fine. Okay, just make a sequence detector for 1011 overlapping.
Okay. Do I have to write code or the signal flow?
All is the signals and all.
1011.
Yeah, overlapping.
One second.
Yeah. Okay, fine. So just tell me the step. I want to convert the SR flip flop to the JK flip flop. You can just write the steps. What will be the step you will follow? I want to convert the SR flip flop to the JK flip flop. Or you can take your time and you can do it like 5 or 10 minutes.
SR to JK.
Yeah.
I'll just write the excitation table of SR and the
You can
characteristics
make
table.
it. You can take
I'll
5 minutes.
Okay. Sir, done.
Okay, yeah, sure. So what are the steps you have followed?
Uh, let's say I have to convert SR to JK,
Mhm.
so I'll excite it. I'll write the excitation table and the characteristics table. So when I write characteristic table, I will match the excitation table of SR and map and write the values, and I'll just find the Boolean expressions for S and R.
Okay, fine, fine. Okay. Uh, you have to calculate the clock clock timing, like time minimum, like you can say maximum frequency. Okay, maximum frequency you have to calculate. Setup time is 50 picosecond. Set whole time is 20 picosecond.
Setup
Clock to
time is 55.
20. 50 setup time is 50, hold
Hmm?
time is 20, and clock to Q is 80. And
80.
combination delay, yeah, 80 clock to Q. And combination delays are 200
Okay.
picosecond. You have to calculate the maximum frequency or the minimum clock period.
So minimum clock period should be greater than or equals to the
Yeah.
combination delay uh, plus the CQ timing that it's taking uh, plus the setup time minus whatever skew they have. So there is no skew, so it will be 330 nanoseconds.
Okay. Okay. You have to cross check it once. You can do it the cross check it later, right? Yeah. Oh, okay. How many two you have to implement like let's say 256 into 1 mux using 4 into 1 mux. So how many mux you will use?
I'll just divide it by 4.
251 marks. 252, sorry,
256.
256 into 1 marks using 4 into 1 marks.
Uh, 84.
Yeah, okay, fine. Just cross check it later, fine. You can check it later. Because I don't have the answers. You can show me the like how you calculated. You can show me the approach. I can tell
Yeah,
you the approach.
I just divided 256 by 4, and whatever I got
Ah,
number,
yeah,
I added it.
approach is fine. Approach is good. Approach is correct. Approach is wise is correct. Okay. Mm. You know about latch interference bug?
Latch?
Latch inference. Latch inference bug. You know?
No,
Latch
I have
inference, you know, don't know. Okay.
Latch inference.
No problem. Latch inference. Okay. Can you write the
Latch inference, it's like in Verilog, I mean, like when I don't write all the if or else, it will infer the
Mhm.
latch. Do you mean that?
Mm, it's in Verilog. You have done in the Verilog.
Yeah. If I don't write, I mean, like if say if there's an enable condition, and if there's a if enable condition is there, but else condition is not there, and it's a
Mhm.
combinational block, so it will
Yeah,
try to
yeah.
save the memory. So is that
Yeah,
latch?
yeah. Similar to that. Okay.
And
Um, so write the FIFO empty condition, full condition. Just the condition you have to write.
before
Yeah.
I type it. FIFO is empty when the read pointer is equals to the write pointer.
Screen is freezing. Your screen is freezing in between.
1 second. Is it okay now?
Yeah, okay, fine. Just write it and tell me. You can write on the like whatever you have. Sure.
I'll write it. When the write pointer is equals to the read pointer, and full is when the write pointer plus its first bit is equals to the read pointer.
Hmm. Yeah, fine. So you have learned about this asynchronous FIFO. You have learned asynchronous FIFO.
Yeah, we had a
So,
project.
so why we use the gray code pointers in this?
Gray code pointers.
Yeah, why we use it? Like why
So,
not binary pointers?
what happens is, 1 second. Yeah, what happens is binary pointers may, when I try to change the value, sometimes it happens ki in one go all the 3-bit get changed. So if that happens due to the physical wire, there's a delay in the physical wires. So there might be a time when instead of, let's say, I'm changing it from 110 to the other value. So there might be a chance where all values might be 111 or 000 or any other different value. It might go to the metastable state, or we can get the garbage value. But if we use gray pointer where only one bit changes at one particular time, so max worst case we can get is if you want a value 7, we'll get 6. Sorry, if you want a value, let's say 4, we'll get 3 or 5. So we can manage that. We won't get any garbage value, and metastability issue won't be there. That's why we use gray pointers.
Okay. So you are saying it asynchronous FIFO provides the metastability.
Yes, sir.
You are saying asynchronous FIFO avoids the metastability.
I'm saying asynchronous FIFO is used to transfer the data without losing it.
So it
And
avoids metastability or not? It avoids or not?
yeah, it does avoid metastability.
Okay, fine. You know about race round condition, race condition, sorry, race condition
Yeah.
in Verilog. So using Verilog code, you have to explain it. What is what is this condition?
Race condition. Okay.
Yeah, race condition using code. Yeah, explain it.
So both the always block will
You have
be occur at the
give a
same time.
equals to you have written, or you are like this is blocking or non-blocking. This is blocking or non-blocking.
Yes.
This is blocking or non-blocking, like blocking
This
statement or non-blocking.
this is blocking.
Okay, fine. Why not blocking? Like,
This is blocking. This is not non-blocking. Non-blocking may I'll get assigned the value after the matlab after the clock edge.
okay,
In
okay.
blocking, it is sequential. It will instantly assign the value.
So in days round condition, it will be both. Which one should be there?
Yeah, it will be blocking.
Okay, fine. Just cross check it once later. No problem. Okay, fine. I have written a code. Let assign a equal b. Assign a equal b
Assign
semicolon
A equal
equal
B
b.
semicolon.
Second line is assign b equal a semicolon.
Okay.
So tell me the what is the problem in this code? Like it what will be the output of this code? Like what is the issue?
So assign equals to base. This will result in a race condition where A equals to B and B equals to A. They'll both fight for the value. It'll be a race condition. The value will toggle.
Okay. It will go to the combination loop. It will be loop.
It will be unknown value. The result will be unknown value. It will go into the loop and it won't stable at the single point or a value.
Okay. Okay, fine. So basically it will go to the infinite loop. It will be an stable condition and no defined hardware will be there. No issues.
Hmm.
Can you write the code for the priority encoder 4 by 2 priority encoder?
Yeah.
Just write the code for this. And why we use the priority encoder? Tell me the reason also why we use it specifically.
Because sometimes we want a particular input to affect the output. But if there's a presence of higher degree of the binary digit, and if it's on, the output will be according to that bit. I'll first write it down and then I'll.
Yeah, sure.
So,
Yeah. Let me check. Fine.
so
So,
basically,
mm,
I mean, like when output is dependent on many input, like many input drives the same output. So that's when we use the priority encoder.
mhm. Can you write the code of Verilog for this? Can you write the code?
Yeah.
Yeah, show me just the logic I want to see.
Oh, yeah. I have written for the third part, just the third part.
You are writing the output, okay. But where you are giving the condition? Okay. Okay, you are giving in a decimal form. Okay, fine. Not in the binary form.
No, it will be easier to write, that's why.
Okay.
Or like, I can write it once again.
No problem, no problem. Do it later. No problem. You can check it once also later, fine. Because like it should be in binary. Okay, fine. Also, why we use the pipelining? Like one reason is throughput. What is the another reason?
We can run the whole system with higher frequency. The system will be faster.
So it help in getting the like better critical path also.
Yeah, the critical path, the longest combinational delay would be reduced.
Okay, fine. Fine. So let's say suppose I have the three stage pipelining hardware. So you just have to write the rough code. How you will write the code
Uh,
for the
the,
three-stage pipelining.
okay. So basically, the thing that I did with RISC-V, that what code do you want me to write?
For the
In
stage one, stage two, stage three. Let's say I want to add like any a plus b,
Okay, okay.
something like that. Or we can say like that I want to implement the ALU using a simple code and using a pipelining like code. Like what will be like methods if I want to calculate like faster using pipelining
So if
concept.
there is a three stages and the instruction is y equals to a plus b. So first stage will be the inputs, capture of inputs. All the inputs will be there in the registers. Second will be the computation, where I'll compute the sum and store in the sum stage. And the third stage is where I'll transfer that sum into the output.
No, I am saying like first stage let's say you are adding all the instructions. So like you are giving the instruction.
Hmm.
Second, you are using the second this first stage output and the other element you are using, which is the new output, right? And
Hmm.
like that, right? So you can
I'll
check it
write the
like how to like
okay.
implement some logic using the pipelining, right? You can see the code at least, right? Okay. So like I will like the as propagation,
What?
I asked you this similar question last in the interview also. X propagation. What is X propagation?
I didn't get you. I cannot
X
understand what you
propagation.
said.
X propagation. X
X,
propagation. Yeah, X means like
X for quotation.
X propagation.
No, I don't know this. XOR operation.
X or propagation means undefined. X is undefined, no?
Oh yeah. Oh, X notation.
Propagation.
Oh, X propagation.
Yeah.
Okay.
You know
X
what this?
propagation.
Okay, no problem. How you treat how synthesis will treat for the for loop. So like it if we have to implement the some loop, right? So how the synthesis will occur for it?
Can you repeat the question, please?
How synthesis treats for loops?
How synthesis?
Treat the loop. Like I have the code for the loop, right? How synthesis will occur for it, like. Okay, no problem. You can check it later. No issue. Uh, okay. You know about glitching? Glitch. You know.
Yeah, yeah.
So tell me about the glitch. What is the impact of it? Glitch and where how we can reduce it.
Glitch is basically the unwanted short pulse that happens, and it sometimes propagate also. It causes delays in combinational path.
Hmm.
It can be a static one or static zero or the dynamic hazard.
Hazards and glitch are the same.
Uh, yeah, I mean like glitch is hazard, so there's static
Okay.
zero, static one.
Okay, fine. Just check it once. Okay, if I am saying I am using a blocking statement in the combinational circuits and non-blocking in the sequential circuits. So this is the correct statement or not?
Yeah, this is correct. Non-blocking for
Can you
sequential,
explain?
and
Can you explain it why it is happening
in
so?
combination circuit, non-blocking statements are actually used when the right-hand side of the value is evaluated and put in the left-hand side when the clock edge comes. But in the combinational circuit, there is no such thing as a clock edge. So blocking works best for it because as the moment we turn on the circuit, it will start simultaneously. Sequentially, it won't stop. And for the non-blocking statements, it happens in sequential circuits, basically because it has clock and it will wait for the clock edge to assign the value to the LHS.
Okay. So it is general term like or it is like compulsory we have to do it. Like
It
we
is
can
not
ignore
compulsory. It is not compulsory, but if we did it in the other way, there might be problems like we won't get the right value in the sequential block if I use
that.
the blocking statements there.
So you know about linting? Lint, you know,
No.
lint in RTL design. Okay. You have the idea like what is lint? Just the basic idea like what why we use it. Lint.
No, no, I don't.
Okay, fine. No. So you have done some questions like debugging questions also, like for the interview preparation.
Yeah, I have done C programming and Verilog debugging questions.
Okay, fine. So let's say just write the code I'm dictating. Always at the rate bracket a bracket
Always.
close. Always at the
All
rate
yes.
bracket
Hmm.
a bracket close begin.
Yes.
Next line is sorry, y equal a and b. A and means like of like a and symbol. So b semicolon and.
Huh.
So tell me like what is the problem in this? Like it will run like it what will be the output?
Always at the rate star begin.
Not
Uh,
a in the sensitivity I have mentioned a.
okay,
Okay.
okay. So the Y will only change when A will change. Let's say if B changes, it won't show any effect in the Y. It won't execute.
Mm-hmm.
So that's why we put star there to sense all the changes, all the variable changes.
Mm-hmm. If we don't do it, if we don't like simply write a, so what will the problem will occur?
It will be, matlab, it will be block triggers like only when A changes. So but the output is dependent on both A and B,
So
but
say
it'll
is
only
will
do when
it
A changes.
will show the effect in the synthesis part or not? Like
No,
synthesis.
it won't show the effect in the synthesis part.
Okay, fine, fine.
I mean,
So.
it won't show the effect of B in the synthesis part. It'll have the bad
Mm-hmm.
effects in the synthesis part, basically.
Mm-hmm. Other problem can be like like let I have given the if statement, but I have forgotten the else statement, right? So this type of the question they can also ask, right? Got it? They have given the if condition, but they have not given the else condition, right?
Hmm.
So for the better, like if otherwise it will go to the no unsafe condition,
Hmm.
unsafe state, right? So for the safe state, you have to write the else condition also. So
Hmm.
that that debugging question they can give you. Hmm. Okay. So my next question is always at the rate
Always at the rate.
bracket postage
Hmm.
clock
Yes.
bracket close begin a equal b semicolon b equal a semicolon close end.
Semicolon B equals A.
Hmm.
So here I've used blocking statement in the sequential design.
Hmm.
It'll lead to the wrong behavior or a race condition.
Hmm.
Uh, it'll,
Okay.
I, it will happen sequentially. So A will get the old value of B, but now when B equals to A happens, so basically because A is already updated, so B will get the new A, which is the old B.
Okay,
So both
fine.
will be
Fine. So basically for the parallel updates, we have to use non-blocking. Fine. Okay.
huh.
Okay. Uh, so you have written the always at the rate postage clock inside bracket.
Always at the rate.
Always at the rate postage clock
Yes.
q q non-blocking a q non-blocking statement a semicolon closed, and another line we have written always at the rate postage clock q non-blocking b. So it will work or not? Like,
It will throw multiple driver errors. I mean, like
okay,
both the
what do you mean
things
by?
are fighting.
So it like multiple driver. What do you mean by multiple drivers error?
Multiple drivers means at the same time when the it's writing, so Q is
Hmm.
getting both A value and B value. That is not possible.
Hmm.
Q can take only one value, so there will be an error issue.
Means,
A flag will
I
be
have to
displayed.
use the always block once a time, right?
Yeah.
Okay. So how you will do it? Like you will write a like how you will do it? Like what will be the extra thing you will add? If I want to fix it, I have to add some parameter to it to fix it.
I can add I can add enable in there if enable A, if not B.
Yeah, yeah. Okay. Fine. Okay, just write a code. If bracket select
If
close bracket select bracket close
yeah,
y equals a semicolon else if uh,
else if
not select means not
hmm,
select bracket closed y equals b semicolon closed.
hmm.
So what is the problem in this? Like it will what will be the output of it? Like
I have not written the default condition here. If it's select, it will select A. If it's not selected, it will give B. But the
hmm.
default condition is not there. Like if, but else is not there. It will
Okay.
infer latch.
Hmm. Got it. Yeah, fine, fine. So basically, what they will do, they will like give you the 20 lines code or 30 lines code, and they will ask you to debug it, right? So all those small things will be there, right? Like कुछ ज्यादा बड़ा नहीं होगा, ये छोटी मोटी चीजें का करते हैं वो, है ना? तो अभी हम नेक्स्ट राउंड कल करते हैं बिकॉज ऑलरेडी 1 hour इज गॉन, राइट? सो यू
हाँ,
हैव एनी डाउट?
मुझे ये पूछना था कि वो जीपीयू में कितने डीप तक के जाके पूछ सकते हैं, लाइक वहां पे उनका उन्होंने ऐसा कुछ लिखा तो था नहीं, तो
बेसिक पूछते हैं, ज्यादा पूछते नहीं है। जीपीयूज कंप्यूटर आर्किटेक्चर से पूछेंगे, कंप्यूटर
अच्छा।
आर्किटेक्चर से ज्यादा पूछेंगे। जीपीयू का तो बेसिक्स आना चाहिए, वही जो भी बताया।
और फिजिकल डिजाइन मेरा एक फ्रेंड बता रहा था, उसका एक फ्रेंड एनवीडिया में है, तो वो बता रहा था उसे कि अभी जो एनवीडिया वाले हैं वो मतलब फिजिकल डिजाइन को मतलब उनको ज्यादा प्रेफर कर रहे हैं, तो वो बहुत ज्यादा डीप में जाके पूछ सकते हैं क्या फिजिकल डिजाइन को?
फिजिकल डिजाइन के सारे स्टेप्स पता होने चाहिए अच्छे से, सारे स्टेप्स अच्छे से पता होने चाहिए फिजिकल डिजाइन की। फ्लोर प्लानिंग में क्या
फिज-
होता है, प्लेसमेंट में क्या होता है, राउटिंग में क्या होता है, राउटिंग दो टाइप की क्यों होती हैं। तो सारे स्टेप्स एक बार आप यूट्यूब पे देख लो, हमारे चैनल पे,
हम्म।
हमारे यूट्यूब चैनल पे प्लेलिस्ट पड़ी है ना उसकी।
हाँ,
तो
मैंने
सारे
देख।
सारे स्टेप्स आप वो देख लो कि क्या 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 स्टेप्स में, कि एक एक मतलब सारे स्टेप्स को 1-2 घंटा देख लो, है ना? तो हो जाएगा।
हम्म।
ऐसे नहीं कि खाली डेफिनेशन से नहीं हो पाएगा, एटलीस्ट 20 घंटा देखना पड़ेगा आपको फिजिकल डिजाइन। लेकिन हाँ, कोड वाला चीजें नहीं पूछेंगे, कैडेंस वाला नहीं पूछेंगे वो, है ना? लेकिन हाँ, फ्लोर प्लानिंग, पावर प्लानिंग, सीटीएस राउटिंग, है ना? कितने टाइप्स की राउटिंग
उन्होंने
होती है।
ना उनके जो ऑनलाइन असेसमेंट था
हम्म।
उसमें पूछा था, तो मैं एज सच उतना कुछ पढ़ के गई नहीं थी वहां पर, बट मुझे पता था कैसे होता है थोड़ा बहुत, और वहां पे उन्होंने ना फॉर्मूलाज वगैरह सब दे के रखा था।
हाँ, तो वही मैं कह रहा हूँ ना, सीटीएस से जैसे सीटीएस है, राउटिंग है, उसके एल्गोरिदम क्या है ना? छोटा छोटा पढ़ लो, ऑब्वियसली ज्यादा डेप्थ में तो वो भी नहीं जाएंगे, है ना?
हम्म।
उनको बता देना कि मैंने मतलब बेसिक बेसिक पढ़ा हुआ है ना? तो थोड़ा बताना पड़ेगा, है ना? तो एक मतलब 20 घंटा भी ऐसे चाहिए, फिजिकल डिजाइन पढ़ लोगे यूट्यूब से भी, हमारे चैनल पे भी पढ़ा हुआ है काफी सारे कंटेंट, प्ले लिस्ट पड़ी हुई है और ऐप में भी है। तो डेट इज मोर देन सफिशिएंट, राइट? क्योंकि टूल वाले पार्ट में तो ऑब्वियसली टाइम लगेगा, उसमें तो टाइम लगेगा।
हम्म।
तो वो ज्यादा पढ़ लो, वही सफिशिएंट है। बाकी कंप्यूटर आर्किटेक्चर वगैरह है। ओके देन मानसी, गुड नाइट। ओके मानसी, थैंक यू, बाय।
थैंक यू।